So just as an exercise, I wanted to go through and sort of completely analyze a transaction that I found in the blockchain. Um, I got this one from blockchain.info. It was just an interesting transaction that was in a recent block. This says one confirmation. That means that this transaction has been included in one block, which is this one. That's not true anymore because a lot of time has gone by since I opened this web page. So if we were to open this transaction again, we would see that it has now many confirmations. So that means that it's got 31 blocks on top of it, and so it's very securely on the Bitcoin blockchain now. And actually, both people have gone ahead and spent the transaction outputs. Um, so let's look at it as it was, though. You've got an input address going in and an address going out. And this starts with a 3. It's probably a SegWit address, but it could also be a pay to script hash transaction. Notice that the output address here is the same as the input address, so this is probably the change. It doesn't have to be the case that change goes right back to the sending address, but this person doesn't care about anonymity, and so they don't, this compromises your privacy a little bit, but if you don't care, then you're welcome to do it this way. This person has quite a lot of Bitcoin um, associated with this address, um, about $757,000 worth. Okay, so some other information here. You have the size in bytes. It's 224 bytes. Now there's also this figure, which is the weight. So that's a sort of a post SegWit thing. Um, Segregated witness is an idea for fixing several things. We'll have to talk about it at some point, but it's very complicated, and I don't know how much time we can spend on it or how much time I want to spend learning every detail about it. But it's made some of this stuff in Mastering Bitcoin obsolete. But there is an entry, there's an appendix in Mastering Bitcoin that talks about SegWit that you might find interesting. Um, this weight thing, notice that this is just 4 times that. So the idea is that in an old school transaction, which I guess this is, the weight, you compute this figure called the weight, and the weight is 4 times the size in bytes. And so you might wonder what's the point. So now, um, oh, what's going on here? Yeah. So now the every block has a weight limit instead of a size limit. So the maximum weight of a block is 4 million. But that's still just 1 million bytes, which is 1 megabyte, which is the same as it always was. The difference is now you can do a SegWit transaction in which some of the information in the information in the transaction comes along at a discounted rate. You can kind of look at this article a little bit. Where is it? Weight units. Just to get an idea, let's just look at a picture. So this is sort of an old type transaction. And below we have a SegWit transaction. And so the things in blue are the witnesses that are segregated. So a witness is just a fancy word for a signature. Signatures take up most of the space on the Bitcoin blockchain. So when they're segregated, it means that they're stored somewhere off the blockchain and they're sort of just linked to somehow in a transaction. Um, and so the idea with weight is that the information in these blue regions can come along at a rate of 1 byte. 1 byte unit translates to 1 weight unit. But for the fields that are in white here, 1 byte will cost you 4 weight units. So what SegWit does is it gives you a little bit of a discount on transaction fees for the signatures if you are using SegWit transactions. And so surprisingly, most people, it seems, are still not using SegWit. That might be because a lot of people use online wallets like Coinbase, etc., and they have not upgraded to SegWit yet. So everybody who's using an online wallet that um, is still using legacy transaction types, is using these old Bitcoin addresses. And I suppose that that's why most Bitcoin addresses still begin with a 1. So let's keep going through. This, at the time, there was one confirmation. Visualizing it is not very interesting here, but it might be more interesting if we visualize what's happened here. Not really. All right, so now this discusses the inputs and outputs. So the, this is interesting. So the, is this right? Oh, I see. Okay. So what is this number? Total input. So that's the sum of all the inputs. There's only one input in this transaction, so that's very easy. That's just that number. Now the total output is the sum of these two. And notice that these don't exactly match up. There's a little bit left over, and the difference is implicitly a tip to the miner, or a bribe, or however you want to think about it, to persuade them to include this transaction and a block that's coming soon. And this transaction fee is actually quite high. It's $56. So at certain times, I personally have paid $120 for a transaction before, I'm ashamed to say. But at the moment, if you look at current Bitcoin fees on this website, bitcoinfees.earn.com, you can see that you can get included in the next block for a rate of 51 satoshis per byte. So let's see if this person had paid 51 satoshis per byte, what would they have been looking at? So you've got 51 satoshis. So that is, let's translate that to Bitcoin. So divide by 10 to the 8. So it's that much Bitcoin, and Bitcoin per byte, and let's multiply times the size of the transaction. The transaction was 224 bytes. Okay, so that's the total amount of Bitcoin that it cost to make this transaction. Now let's multiply times the current exchange rate of Bitcoin, which is about $9,200. And so, I don't know what's going on, but this person could have gotten included in the next block for a fee of $1.05, and yet they chose to pay $50. This person apparently is quite rich, but that's pretty striking, and it's up to the wallet software. Probably what happened is the wallet said, would you like to make this a high fee transaction? And the person said yes, because they wanted it to confirm quickly. And then the wallet just did a bad job of sort of dynamically deciding what a reasonable transaction fee would be. So they overpaid by a lot for this particular transaction. And that's something that you should keep in mind when you see these scary stories about the average cost of a Bitcoin transaction being really expensive. Frequently, people are just overpaying by ridiculous amounts. And that may be something for you to think about if you are making Bitcoin transactions yourself. Like an interesting project might be to do a better job of doing the fee estimate. That might be sort of an interesting semester project if you want to start thinking about that, is seeing if you can come up with a better fee estimator. All right, let's keep going. So fee per byte, this is Satoshis, so we divide by 10 to the 8 to get it back to Bitcoin. Fee per weight, okay, so I just went ahead and used the bytes because this is a legacy transaction where the weight is just 4 times the bytes, so it doesn't really provide any more insight to do the algebra with this number instead. And estimated Bitcoin transacted, that's about right. That's what this guy got paid. And down here you can see some scripts. So there are some, this is an unlocking script for the input. And the output scripts have locking scripts. Unfortunately, that terminology is not standard. Andreas Antonopoulos uses it in the book Mastering Bitcoin. I think it's very clear. But the more common term for these things is this is, gosh, what is it? Script SIG. This is a script SIG because it includes a signature. And these are script pub keys because they include public keys. So among other things, what I'd like to do is look at yeah, so I did this earlier, but I haven't figured out how to pause the recording, so I don't want to make a mistake and have to record this whole thing again. So I want to say some more about these numbers, but I'm just going to call this video part one and start up again in a second.